Okay, today we're going to talk about dynamic fluids. Up to this point, we've only been looking at fluids that are at rest. Today, we're going to make our fluids move. We want to know how quickly they move, and that's what flow rate stands for. Flow rate measures, and we can write flow rate as FR, the amount of volume per second. So if we want the flow rate from this faucet, we would need to know how much volume came out in a given amount of time. The standard units for flow rate would be meters cubed per second. To get a better visualization of a cubic meter, realize that a cubic meter is 1 meter by 1 meter by 1 meter. It is a really large volume. In fact, it dwarfs this 1 liter bottle. It would take 1,000 1 liter bottles to make 1 cubic meter. Okay, on a large scale, something like Niagara Falls will have a tremendously large flow rate when measured in cubic meters per second. But for most common things, expect to get flow rates that are very small numbers. That does not mean they're not flowing quickly. In fact, one of the highest flow rates you're going to encounter in your normal life would be the flow rate of water from a fire hydrant, and you could see how small a number the flow rate happens to be. So don't be alarmed with really small flow rates. Unfortunately, you're going to encounter a lot of different units, so I'd like you to create this chart showing the conversions from one unit to another that you're going to need to work with flow rates. Part of your grade for today is for having this chart neatly put in your notes. You need this chart for your conversions. I'd like to focus on a couple of them that are a little bit hard to understand. Okay, so these bottom four are actually like a calculation to show you where this conversion comes from. So a cubic meter would be a meter by a meter by a meter, which if we were looking in feet would be 3.281 by 3.281 by 3.281 feet. So to get 1 cubic meter, you have to multiply 3.281 3 times. You cube it to get the conversion from cubic meters to cubic feet. It might be easier to see if it was a cubic yard. A cubic yard would be 3 by 3 by 3. Okay, so a cubic yard, when they're talking about that in construction, 1 cubic yard would be 27 cubic feet. 3 times 3 times 3. With cubic inches to cubic feet, again, it's 12 inches in a foot, but you have to do the 12 inches 3 times. So it's 12 times 12 times 12. Down the bottom, an acre foot, crazy unit, but it's used a lot when we're looking at water usage in agriculture or just water usage in a community. They measure acres for the area times 1 foot deep. So 1 acre foot worth of water would be an acre flooded to a depth of 1 foot. It's a real convenient way of measuring the amount of water in something like a reservoir or a lake, or how much water has fallen on a farm. Okay, so the second thing you really need to have besides that chart, also obviously you need the definition and formula of flow rate, is I'd like you to do a bunch of conversions. You are going to encounter all kinds of different units for flow rate, and I want to make sure you can convert them. You can convert them. So set up a factor label problem. I don't care about the answer. I want you to get an answer, but I'm grading you on your process, so keep it neat and work through the conversion from gallons per minute, which is what is used by John Deere to measure the flow rate of this pressure washer, and convert it to meters cubed per second. Do that for all of these. The air purifiers that Delcy just bought are in cubic meters per hour. Convert it to cubic meters per second. I don't care about the answer. I want to see the process. Show me the process to turn cubic feet per minute, which is what Home Depot uses to measure exhaust fans, into cubic meters per second. In a hospital, they measure the flow rate of air into a patient in liters per minute. Show me the process to turn it to cubic meters per second. For the drip for intravenous, they might do milliliters per hour, convert it to the standard that we need for calculations. Here is Pittman's little stream coming out of our lake, and the U.S. Geologic Survey monitors not just the one in Pittman, but all over the country. They have these little stations that they monitor flow rate. What they're looking for is they're looking for areas that may be potentially subject to flooding or drought. And they plot out this data on a continuous basis, and I just want you to convert the cubic feet per second into cubic meters per second, showing me again the process. Here's the device that actually measures it. Here is a device that is actually trying to calibrate to make sure this machine is doing this properly. The students you see in the background here are the students of a former student of mine. His name is Dr. John Gannon. He is a professor of hydrology at Virginia Tech. And one of the things his students need to be able to do to keep our country safe is to be able to measure the flow rate at different points around the country to monitor for when we're starting to have drought conditions and when we are in danger of having floods. This is particularly important in the desert Southwest, where there are way more people than there should be. So we have to manage our water really carefully. And the scientists there, when visualizing how much water there happens to be in a reservoir, use acre feet per day to measure the flow rate either into or out of the reservoir. And I want you to convert it to meters cubed per second, again showing me the process. Okay, so that's a major part of your notes for today, and I'm grading you on how good you do those factor label. And again, I'm not looking at the final answer. I'm looking at how clearly you write out the process. The other thing you want to do today is show me that you can use our flow rate equals volume over time to figure out how much time it would take something like a hose to fill a pool or some other similar structure. So you have two problems you need to do. The first one, we're going to fill this cylindrical pool that happens to be 7 feet in radius. We're going to fill it to a depth of 3.3 feet. So find the volume of water we're going to put into the pool. We're having a flow rate of 9 gallons per minute, and I would like you to find the time. Make sure you convert everything into meters so that your volume is in meters cubed, and make sure you turn your gallons per minute into meters cubed per second. When you get your final answer in time, it will be seconds. Convert it to either minutes or hours, whatever is more convenient. The next one we're going to do is I want you to learn how to figure out how quickly we can get rid of stale air in a classroom. This is a very important thing, again, for architects to be able to make sure that they can keep a building healthy. Even under normal conditions, it's important that we get rid of all the CO2 that people are emitting and get fresh air into the room. So all rooms will have some kind of ventilation, and we're going to assume that we use that exhaust fan that we saw at Home Depot. So 225 cubic feet per minute. Again, use the value in cubic meters per second. Figure out the cubic meters in my room. Use your formula, flow rate equals volume over time, and figure out how much time it would take to get all the air out of that room and have fresh air come in through either an open window or through the cracks underneath of the door. And once you start pulling air out of the room, it's going to drop the pressure in the room, and air will just naturally come into the room. We don't need a second fan to bring new air in. just the one fan to exhaust the room. A healthy building should be able to exhaust all the air in 30 minutes or less. So again, this is not the actual exhaust fan that I have in my classroom, but see how effective it would be if this is the one we installed.